For today's project, we are going to be civil and mechanical engineers and create our very own creative launcher. Our launcher will use the laws of conservation of energy to launch objects.
Now that we know what we're making, let's make sure that we have all of our materials ready. For this project, you will need 5 pairs of chopsticks, 3 cotton balls, 2 16-ounce plastic cups, 1 paint stick, 4 medium rubber bands, 5 large paper clips, 2 toilet paper rolls, 1 bottle cap, and 1 double-sided square. Outside of your project bag, you will also need a blueprint worksheet and 3 sheets of printer paper. You will also need, for testing, 5 ping pong balls, and you will need a class set of large cardboard pieces. Outside of your project bag, you will also need some tape, some scissors, and a pen or a pencil. Once you have all of your materials ready, we can start building our project.
First, we need to create our blueprint. Remember that because this is an engineering design challenge, everyone's launcher will look different and will most likely not use all materials or might use even more. We will be creating the sample solution. To start, we need to plan a base for our launcher so we can build our launching arm above it. For this sample, we are going to use 2 plastic cups as our base. And in this case, I'm drawing the cup upside down. Once we have our base drawn out, we then need an arm and some way to attach this arm in a way that will allow us to have our arm swing. To do this, I'm planning that I'm going to be using 2 pairs of chopsticks in a cross with a rubber band tying them together in the middle and attaching them loosely with some tape on top of each cup. I'm going to use a rectangle to represent our pairs of chopsticks. And here is the second arm. And I'm going to draw an infinity sign for our rubber bands. And I'm going to draw some tape to let me know that I'm going to be adding tape here. Also, we need a bucket to store items so that when we pull back on our arm, we'll be able to launch whichever items we fill the bucket with. So I'm going to add a bottle cap to the end of my chopsticks arms. I'm also going to keep in mind that I want to put it a little further from the edge so that I have a place to place my finger. And this circle is going to represent my bottle cap. Finally, we need a fulcrum that will allow our arm to retract back. To do this, I'm going to add another pair of chopsticks to the base of my plastic cup and attach it to the other plastic cup. And again, I'm using a rectangle to represent this. You could also draw another line in the middle to show that this is a pair of chopsticks. And we're going to be using some tape. But then we need to somehow create energy between our fulcrum and our arm. I know rubber bands are very useful when it comes to increasing potential energy and to launch objects, so finally, I'm going to add a rubber band that will allow our arm to be pulled back. And I'm going to place it right in the middle of our chopstick pairs. Again, I'm going to use an infinity sign to represent this. But this just lets me know that I'm going to be using a rubber band attached to our fulcrum and the bottom of our arm, so that when we pull back, the rubber band will pull it back and allow our object to be launched. With that, I have a clear idea of what I want my own launcher to look like, and we can get started on the creation step. These instructions will show the sample solution that we created on our blueprint paper to show any students who are struggling to come up with an idea for a launcher. Have those students follow along while others create their own. Let's get started on creating this sample solution. First, grab 2 pairs of chopsticks and place them perpendicular to each other. And in this case, just like our blueprint paper shows, we're trying to make a cross with them. Use 2 of your rubber bands to secure them together by twisting them multiple times. And on my blueprint sheet, I drew 2 rubber bands because I wanted to twist them around in a cross for the best secure connection between our chopsticks. And to do this, we're just going to keep wrapping along the middle of our chopsticks. All right, now that I have 1 rubber band placed, you can see that my chopsticks are pulling away from each other, which is why we want to add another rubber band along the other diagonal. And you should notice that the chopsticks do not move anymore and it looks like a cross. You will know when you're done, again, when the chopsticks do not move around easily. Next, grab 2 cups and place them upside down about 1 chopstick length apart. And you can measure this by just grabbing your cross and quickly measuring it out. And this looks good. Then, tape the ends of 1 pair of your chopsticks onto the cups. So we're going to grab our chopstick cross, we're going to place it on the cups, and we're going to secure it down with a piece of tape. You will notice that the other pairs of chopsticks are just floating and are not attached to anything yet. You should also be able to move these around freely, and it's okay if the cups move a little. Take a rubber band and thread another piece of chopsticks through it. Like this. Make sure the rubber band is in the middle. Attach this new piece to the front of your 2 cups using some tape. So I'm going to place it on the front of my cups, and I'm going to tape it down. Using the rubber band that's in the middle of the newly attached chopsticks, use some tape to attach it to the closest chopsticks from the cross, which will be these ones. You may need to pull down on this cross-shaped chopsticks to secure it in place. But once that's done, we can move on to the next step. Once you've securely attached the rubber band to your launcher, we're going to add a bottle cap to the other end of our cross. To do this, we're going to grab one double-sided tape and attach it to the flat end of our bottle cap. Then we're going to peel off the other side of our double-sided tape. And on our launcher, we're going to secure it onto the free end. Again, just like my blueprint shows, we're going to put it a little bit far from the edge so that we have a place to rest our finger. Once you have done so, you are finished creating the sample solution and we can move on to testing. Now that we are finished creating our sample creation, let's test it out. To test it, we're going to load our bottle cap with a cotton ball, and we're going to hold down our launcher with one hand. Preferably, you can hold down these two chopsticks at the bottom. With your other hand, you can use your finger to pull down on your arm, and when you're ready, let go. Now, obviously, I can make it more secure. That way, our launcher is a little bit stronger and it's able to launch a bit further. But you can also create some targets to challenge your students to see if they can hit them down, or you can have them see whose catapult launches the farthest. Now that we are finished testing, let's talk about how it works. A launcher has a fulcrum that allows us to create elastic potential energy using the rubber band at the bottom. When we pull down on our catapult arm, we're able to increase the amount of potential energy that there is, and when we let go, all of that potential energy is converted into kinetic energy. The more we pull down, the higher our potential energy is, and thus the more powerful our launch will be. Although your students may have different creations that may or may not be a catapult, launchers in general follow the concepts of the laws of conservation of energy, which is how we are able to launch our objects fairly far. Some questions your students can think about are, is your launcher durable? How can we make your launcher launch objects farther? Or was it easy to create a launcher with the limited amount of materials that they were given?